All right, hello everyone, this is Mr. Croce. I want to give you some help with continuous growth or decay formula. And here's our formula. It's A is equal to P, E, RT, and the R can be positive or negative. And what this is it's a positive growth rate where the growth starts off slowly and it starts to speed up and then gets faster and faster. And that's what happens when this rate is positive. But when this R rate is negative, we have decay rate, meaning it goes down quickly, then it kind of slows down this way. So here's our story problem. It says a school of 500 fish is continuously decreasing at a rate of 20% per week. So that means we're going to have one of these graphs here where it goes down and it just keeps getting lower and lower and lower, and it's decreasing, it's decaying. Well, we use this formula to figure it out, and we have A for the amount, P's principal, E's a number here, and it's about 2.71. It's kind of like number pi. It's an irrational number that we use in here that gives us the answers for continuously decreasing. So when we see this word continuously, we have to use this number E in our formula. We put the rate plus or minus in the time period, and here's what the formula looks like to match this story. We have an amount, 500, multiplied by this E value, but raised to this exponent. All right, so let's go ahead and start filling in some charts. And we'll try and figure out inputs here and outputs here. Well, let's plug in week 0. Where is the school of fish at week 0? Well, we already know 0 is the starting, so it should be 500, but let's see how we get this. X is equal to 0. So A is equal to 500 times E to the negative 0.2 times 0. And then we can just use the order of operations to figure this out. Well, we can do this part in our head, right? 0 times this is 0. E to the 0 is 1. 1 times 500 is 500. So there's our starting amount. And if we want to go forward and do another one, let's say 3, well, we can come out here and say X is equal to 3. So A is equal to 500 times E, that exponent with a 3 there. Order of operations will give us the answer. This is a calculator problem here. 500 times E, and a lot of times on your calculator it'll put the exponent up there for you. Negative 0.2 times 3, parentheses, press enter, 274. So the fish population started here. 3 weeks later we're down to here. All right, well, let's just do a couple more numbers just to get some other values in here. Plug in a 6. On my calculator, I can go up here and change that 3 to a 6. At week 6, we're at 151. Let's change that 6. Let's do one more to 12. Plug in a 12, and we're at 45. All right, so let's graph these points here. Week 0, 500. Week 3, 275. Right there. Week 6, 151, right there. Week 12, 45, right there. And you can see that pattern, can't you? That pattern goes down quickly, and it kind of slows down. The rate slows down. All right, but what if we want to work backwards now? And here's where we're going to have to use some logarithms here. Let's say if I want to figure out when was the amount 400, what is the x value? So we're going to come out here and we're going to say y is 400. So we're going to put a 400 here and 500, and we are going to solve this equation, try and figure out what this value is up here, this w or this x. Well, this requires logarithms, and this is our work that we've done mainly this unit. So let's solve for this variable. So we're going to do operations at both sides till we get to that w. Let's divide this over here. If I divide that, I have 0.8. 400 divided by 500 is 0.8. And now I want to bring this down to the front, but the only way I can do that is if I have a logarithm. So I'm going to take that ln of 0.8, bring this one down on this side, and I have the ln of e. So by taking the natural log of both sides, I'm allowed to bring this to the front. It's a rule of logarithms. All right, well, let's see here. Well, I know what this is, right? ln of e means log base e of e, what exponent do I need to go from e to e? Well, that's just 1, so this is just 1. So I really have 0.8 is equal to negative 0.2w. How about we divide that over there? So the w is ln of 0.8 divided by negative 0.2. Time for the calculator. Natural log of 0.8 divided by negative 0.2, 1.1. So at week 1.1, it's exactly there. And you could test that out, couldn't you? Couldn't we go back and put in here 500 times e, negative 0.2 times 1.1, and we're going to get real close to 400 because we rounded. All right, I'll do one more with you. Let's say, where's it at 200? Well, this formula is going to stay the same. Y is equal to 200. We're going to do the same plan, but we're going to put a 200 over here. Let's divide this over to that side, and what do we have? 0.4. E to the negative 0.2w. Let's bring this down, but that's only possible if we're dealing with logarithms, and we might as well deal with a natural log since we have e. That's 1. So w is equal to ln of 0.4 divided by negative 0.2, and you'll see the pattern comes out all the time. 0.4 still divided by that rate. That rate didn't change. Whoops, we have it typed in here wrong. Natural log 0.4 parentheses divided by negative 0.2, 4.6. Oh, it was right. Sorry about that. 4.6. And we have that value there. I'll do one more for you. If you do 100, it's at 8. I'm not going to do the math, but it comes out to 8. So let's plot these points right here. At 400, here's 400, it's 1.1. Well, that's right there, right where it should be. Now, what about the 200 line? 200 line's at 4.6. Well, here's 4.6, but right there, right where it should be. In the 100 line, here's 100, and it's right at 8. So 108, look how close those line up. All right, so that's how you can use this equation to build this table, to build this graph, and you see it's an exponential decay. It's going down towards the bottom. All right, for your own, if you want to do some extra work, extra credit this time, go ahead and complete this table and this graph down here. Make your own table, make your own graph. A school of fish is continuously growing at a rate of 22%. Well, that means A is equal to 80 times E. The rate is 0.22x. Make sure you don't put a negative up there. It's a positive. So use this formula. Find all of these values. Show work for them, please, for all of those forwards and all of those going backwards. The scaling will work as if you make it from 0 to 12 down here for 12 weeks. And if you go up to 1200, your scaling will work. And what's going to happen? Well, it's going to be an increase. It's going to go up, not down, because the rate's positive. The steps don't change. All the steps are the same. Just make sure you are using a positive rate instead of a negative. All right, I hope this helps with your work.